Before we get into trig, this first assignment's really pushing us to understand similar triangles. So what is a similar triangle? Well, what it means, they have proportional sides, and proportionality is really a very important thing to understand in mathematics. It's something that you actually see all over the real world. And what's the idea? Well, let's just say AC is 2 and AB right here is 3. If this bigger triangle, which is similar, let's just say this was 8, that means that it's 4 times greater. DF is 4 times greater than AC because 2 times 4 is 8. So what would DE be? It would be 4 times greater than 3, which would be 12. Now, how do you figure this out? You figure it out using the ratios that they need to be equivalent. That's what proportional means, that the ratios are equivalent. So if I set 2 over 8, it should be the same as 3 over 12. And if you simplify both of these, you get 1 over 4. Which gives us like that scale factor. And you should have seen this in some past math classes, which hopefully you did, because this is going to be a little bit of a spin on that, a little bit more difficult. So let's take a look at this first problem. Right triangles 1, 2, and 3 are given with all their angle measures and approximate side lengths. So we're going to use one of the triangles to approximate YW over WX. I mean WY, not YW. Same thing though. So WY over WX. So they're talking about this triangle. We're going to use this triangle, or we're going to use one of these triangles to approximate the value here. Now we're going to try to find the similar triangle to it. There's 3 triangles here. Only one of them is similar. 70-degree angle is the giveaway. And also don't forget about that right angle. They all have right angles though. So if this angle is 90, this angle is 70, they all add up to 180. That means the last angle must be 20 degrees. So there you go. We know they're similar because they all have the same angles. So we're going to use that ratio. We want WY over WX. Actually, it's this side here. So let me just call this A and this B. It might be a little bit easier to think of it that way. So what we want is WY, we want A over B. Now realize what's opposite here. B is a hypotenuse because it's across from the right angle. That makes it the hypotenuse. And then A is this side adjacent to the 70 because it's next to the 70, it's adjacent. And then the third side we would call opposite. So in reference to the 70, this would be adjacent, and this one would be opposite. Opposite because it's across from it, adjacent because it's next to it. So looking at the 70-degree angle, we want the little one next to it, which is 3.4. And we want to also use the hypotenuse, which is 10. We always know it's the hypotenuse because it's across the right angle. And so 3.4 divided by 10, that's the ratio we want, right? We just want that ratio, which would be 0.34 if you put that in the calculator. So that's the idea there. We got to go ahead and find, which are the corresponding sides. So the corresponding side to A was 3.4. Corresponding side to B was the 10. Made the ratio, and that was our answer. Let's look at another one. So this time we're going to use one of the triangles to approximate EF. So we want EF. Let's just call it X. That's the missing side, right? So we're going to find this missing side. So let's find the other similar triangle given. So 20 degrees, let's look for the other one that's, there you go, 20 degrees. And so we have the opposite side of the 20 is X over, what's the other value given? This is the adjacent side to the 20 because it's next to it. Remember, this would be the hypotenuse because it's across the right angle, and this would be the adjacent side. So you really got to get the whole idea of adjacent, opposite, and hypotenuse. Hypotenuse is across the right angle. Adjacent's next to whatever angle we're referencing, in this case the 20-degree angle. And then opposite is the one that's across, furthest from our reference angle. So I'm starting with opposite over our adjacent side of 6. And so I'm going to use opposite, which is 3.4, over the adjacent side. Well, which one? 9.4 or 10? Remember, 10 is hypotenuse because across from the right angle. So we're going to go with the 9.4. And we're going to use this to solve for x, so we'll cross multiply. 9.4x equals 6 times 3.4. Is 20.4. So to solve for x, we'll divide by 9.4 to get 2.26. I'm just kind of looking at that. Double check. Let me double check our answer real quick. Something seems a little bit off about that. Oh, 2.17. So that's closest to 2.2. There we go. So I must have entered something incorrectly there. Okay, another problem here. Similar idea. Honestly, this is probably one of the more difficult assignments, and we got to start out with it. So I'm not a big fan of that. We're going to use the table to approximate AB. So we want to know what is AB. I'm going to call that X. Realize that is the hypotenuse, by the way. And if this was our reference angle, if 55 is our reference angle, then this would be the opposite side. So let's take a look right here. 55 degrees is our angle, and we have opposite over hypotenuse. So opposite over hypotenuse is right here. So we're going to be using 0.82. That would be the ratio for any similar triangle. That would be the ratio of these two sides to any similar triangle based upon the angle 55. So we're going to say that 5 over x, because that's opposite over hypotenuse, right? That's what we're using. So opposite is 5 over hypotenuse is x equals 0.82. Really, that's over 1. Still have my Christmas colors here. So we'll cross multiply. And then divide by divide by 0.82. Is 6.0975. About 6.1, right? And there you go. All right, our last one. We're going to use the table to approximate the measure of angle D. This is a little bit easier. So using the angle D, we have the opposite over the hypotenuse, right? Opposite is across from it, and then this is the hypotenuse because it's across from the right angle. And so opposite of D is 6.1. Over the hypotenuse is 6.7. And opposite over hypotenuse, for that ratio, let's see what ratio we get. It's going to be one of these three, and then based upon that, we can answer with the angle. So 6.1 divided by 6.7 is 0.91. So just working backwards from the other one, so that's 65 degrees. So really, once again, just to really hammer away at this, probably the most important thing to know from this lesson going forward into the trig would be to know that if you have a reference angle, that across from it is the opposite, next to it, basically the side that you trace from that reference angle to the right angle, that's the adjacent, and then last, across from the right angle is hypotenuse, which you should already know from the Pythagorean theorem. But if you know those three sides, and I should have led with these three sides from the beginning, that should really help you in the future assignments.